Hi, welcome back to my channel. Today we're going to be doing chapter 1.2 equations of motion. I know the previous chapters I've been taking a little bit more time explaining them, the previous video was I think 20 minutes or something like that. So I know not that many people want to sit around and watch the entire video, so I'm just going to try to make these videos more quicker, make them more shorter so people don't have to sit through long videos. So yeah, let's get started. So the average velocity is basically the change in velocity. No, the average acceleration is the change in velocity over change in time. So change in velocity can be rewritten as the final velocity minus initial velocity. And so average velocity is equal to the final velocity minus initial velocity over time. So you might remember from grade 11 the 5 famous kinematic equations, which are right here. So it'd be this one, these ones, and it gives you certain scenarios where to use. So if you're not given acceleration, then you should use this one. If you're not given displacement, then you should use this one, and so on and so forth. So yeah, I'm just gonna be doing a few questions with these equations. So practice questions. Hopefully I can make this video a little bit quicker. So practice. A motorcycle is traveling at 15 meters per second forwards and applies the brakes. The motorcycle slows down at 5 meters per second backwards. Determine the motorcycle's braking distance. The speed is 15 meters per second, and the acceleration is 5 meters per second backwards. So, and you know that since the car is braking, it's pressing the brakes, that means the final velocity will also be 0 meters per second. So, if you know all that, but you don't know, you're not given the time you're not given, and you're told to find the displacement. So if you're told to find displacement, you can just look at these equations and look at the variable that is not given. So in this case, time is not given, so you could use equation number 4, vf squared equals vi squared plus 2ad. So vf squared equals vi squared plus 2ad. So vf squared is that 15 squared plus 2 times, I'll say positive means forwards and negative means backwards in this case. So positive means forwards, negative means backwards. And 2 times, since acceleration is backwards, I'll make it negative forwards, times displacement. So 0 squared minus 15 squared divided by negative 10 equals displacement. Displacement equals negative 225 over negative 10, and negative cancel, so that gives you 22.5 meters as your displacement. 22.5 meters forwards as your displacement, because remember, displacement has a direction. Okay, let's go on to question number 2. A man starts from rest, which means initial velocity is 0 meters per second, and then he moves with a constant acceleration. He travels 120 meters, so displacement is 120 meters in 15 seconds. Calculate acceleration. Find acceleration. So you're not given final velocity in this, and you're told to find acceleration, but you're given all these other variables. So if you look at the table here, you know that the final velocity is not given in equation number 3, but acceleration is in the equation. That means you can find acceleration, and since final velocity is not in this equation, you don't need it. So, and since you don't have final velocity anyways, that means this equation will be best fit for this problem. So let's do displacement equals vi times time plus half acceleration times time squared. Vi is 120 meters equals 0 times 15 seconds plus half acceleration times 15 seconds squared. So So 15 seconds squared is 225. 120 meters equals half of 225 is 102.5. 102.5 acceleration. Then this would just be 102 meters divided by 112.5 seconds squared. 1220 divided by 112.5 gives you 1.06, which you could round to 1.1 meters per second squared as acceleration, which is forwards, I believe, or north. It's north, since it's moving northwards. So that's how you do question number 2. Alright, so let's move on to the next question. Question number 4. In a 100-meter sprint, a runner starts from rest, which means initial velocity is 0 meters per second, accelerates to 9.6 meters per second, which is the final velocity, west, and in 4.2 seconds, which means that is the time it takes. So you have the final velocity, you have the time, and you have initial velocity. This here, you don't need to know, you don't need to really think about this. It's just the total distance of the track, but this is not how much the person is running in the 4.2 seconds. This is just the total distance of the track. So you can just disregard this for now. So the question is asking you, calculate the acceleration of the runner. Well, you know that acceleration is velocity final minus initial divided by time. And since you have those two things and you have time, you can just do that. So 9.6 meters per second minus 0 meters per second divided by 4.2 seconds equals 2.29 meters per second squared west. So for part B, you're told to find the displacement of the runner. So how would you do that? So to do this, you could use one of the equations here. So you now have acceleration, because you've calculated, you have acceleration, you have final velocity, and you have initial velocity, and you also have time. And you're told to find displacement. So this equation right here has displacement, initial velocity, time, and acceleration. And this equation here has the final velocity, initial velocity, acceleration, and displacement. So for here you have time, you have initial velocity, and you have displacement, You have three out of the 4 variables. You have time, acceleration, and velocity initial. And for here you also have 3 out of the 4 variables. You have acceleration, initial velocity, and final velocity. So you could use either of these two equations. I'm just going to use this one, equation number 4. So that would be 9.6 squared equals 0 squared plus 2 times acceleration, which is 2.29, times displacement. So 9.6 squared is 92.16 divided by 2 times 2.29. And if you do that, you'll end up getting 20 meters as your displacement west. Now for part C, it's telling you that the runner, after the 4.2 seconds, it runs the rest of the race at a constant velocity. So at the final velocity for the 4.2 seconds was 9.6. So after the 4.2 seconds, the person continues to run at 9.6 meters per second for the remainder of the entire track or the entire sprint. So you know that during the 4.2 seconds, the person ran 20 meters west, and the track is 100 meters, or the sprint is 100 meters. So the displacement or distance remaining, or displacement, would be 80 meters left over, because the whole track is 100 meters, and since he moved 20 meters already, that means 80 meters is left over. So, and since it's moving at a constant velocity is just going to be 9.6 meters per second west. So this, since it's a constant velocity, you can just do displacement is time is displacement over velocity. So that's time equals 80 meters divided by 80 meters west divided by 9.6 meters per second west. So west and west cancel, meters and meters cancel, so you're left with 8.33 seconds. Now you have to remember that the question is asking for the total time of the entire race from the beginning to the end. So you know that from 20 meters to 100 meters, which was the 80 meter displacement, so after the guy stopped accelerating, so after he was moving at constant velocity, once he did start moving at constant velocity, that this is how much time it took him to reach the end of the track. But before that, remember, it took him 4.2 seconds to run 20 meters. So that means that the total time would be 4.2 seconds plus the time taken after that, so 8.33 seconds. So total time would be 8.33 plus 4.2, which gives you approximately 13 meters per second if you round it to 2 decimal places. I mean 13 seconds. My bad, 13 seconds. I was forgetting we were talking about time in this. So yeah, 13 seconds. So yeah, that's how you do question number 4, and you guys can try the rest on your own. And yeah, I'll try a few of these problems in the next video. So I'll make a part 2 of this, and you guys can just watch that.